Okay, welcome in everybody. Let me get to the right one here. This is our Design 300 lecture. It's Tuesday, November 23rd, 10 o'clock. We're on a Google Meet. The, um, the recording is on. And so let's take a look and see what this week is all about. It's about preventing damage. And now, because this is a major holiday week and many people have a lot of things going on, there's nothing to actually turn in. I consider this to be what you would call professional development, where you're reviewing and looking at this information just to keep it in your back pocket and know that it exists. But this is a highly, highly important area of design, and it's one of the main jobs that architects do. Architects are responsible to ensure that the design and the construction follows good principles to prevent damage or failure for the public good. And I've had in my career many opportunities to work on projects, and some of them uh, preventing damage did not go so well. Uh, you can just look at the Champlain Towers in Surfside to see how hard that can be as an architect, where design changes are made by the contractors for purposes of cost or time, and preventing damage is lost in the equation. And sometimes it doesn't seem like it would be a deal. You know, we think of steel and concrete as being pretty impervious to damage, but in this case, it was water damage, and the water damage control and design was not adequate, and it did cause a massive failure with a large loss of life. The Oklahoma Hyatt was another one that was a design change in the middle, uh, because of a construction decision, and it was not appropriately done, and that's where the big catwalk fell, and 15 to 20 people, I think, were killed in that one. And so architects have a grave responsibility for public safety, public health, public good, and the good of the owners. So preventing damage is high on the list of what an architect does. Sometimes maybe it's nicer to be the designer, because as the designer, you're just trying to apply the best practices and best principles, and it's the architect that makes that final decision um, about preventing damage. So let's take a look and see what some of those types of damage can be caused by. And this is just some of them, not all of them. Well, let me just tell you also about a couple of the instances that I was on. And these were all construction decisions that were not fully brought to the attention of the architect, or the supervising engineers um, did not make it a large enough goal to do their proper oversight. So, much like Surfside, but in the construction phase, I did work on a set of concrete and steel structural towers. I had responsibility for the pump and water distribution equipment in the building. It was a 40-story concrete and steel structure. And due to a um, a contractor's decision, they proceeded with construction before certain key elements were approved in the lower floors, and floors 14 through 20 pancaked and came down. And of course, that caused basically demolition and rebuilding of the entire tower. And that was partly a design and partly a contractor's decision. The previous contractor who built the first tower noticed some things that were not clear in the contract drawings and the design and clarified them and basically added cost to do so. And they chose for the second towers a contractor who was not as careful and did not abide by the as-builts that were approved by the architect and went back to the original design and did um, a series of interpretation of the design that was not adequate and had already been decided as not adequate. So that was a real problem. Another one, a contracting engineer decided to do a test of the mechanical system with air instead of water. Air, as you might know, is a compressible fluid, a gas, and when you put it under pressure, it stores a great deal of energy. And so with water, you get the pressure without storing as much energy. And so they did a pressure test of a large gallery of pumps with air and basically blew up the gallery through the about 4 16-inch pumps through the walls, concrete walls, into the cafeteria. Fortunately, nobody was hurt in that one because the cafeteria was empty at the time. But that's another, they're trying to prevent damage by doing testing, and it didn't work out. So those were just two of them. There were other instances that I've been involved with where um, the construction process took shortcuts, just like they did at Champlain Tower, or as in the Oklahoma one, where they made a decision to change the weld and bolting structure of the supports for a walkway, and it collapsed. So, so that's why preventing damage is very important. Obviously, there's a loss of material, there's potentially a loss of life, and your building just doesn't last as long, and that's a cost. So, what do we have, the areas that we can look at that are common causes for damage? And this is not the full list, but these are big ones, big ones. So pest prevention is one of the big ones. And we think of pests, what are they? They are things like rodents, insects, other things that are arachnids, spiders, can be considered to be mold, can be looped in with pests, but that's usually under moisture control. But pests do cause a lot of damage. So pest prevention and elimination is a big deal in building design. Moisture control, that was the cause of the Champlain Towers in Surfside. It was a moisture control problem that caused that failure, and that was from the design point of view, the contracting point of view, and the maintenance point of view. So all of those had something to do with it. So moisture control, and then fire. Fire damage is the third. So pest, moisture, and fire are three of the main um, um, influences of damage. So let's take a look. Now, there's nothing to turn in about this. There's no submittals this week. This is considered professional development for your knowledge later on. You may or may not get into this type of design where you're responsible for this, but it's fairly important. So let's take a look at some of these resources. And these are heavy duty resources. One of the goals of showing you this is to find out for yourself, do an introspection to see if you're able to read these easily, or get information out of these. Many of these are fairly large documents that you might need to get into as part of a design process. Designers do more than just draw pretty pictures and make documents. It's an important facet is to know your subject. And it's not our goal to teach you all the subjects that you might need to know in the design world. That's what you gain experience when you're doing design. That's what experience does for you. But it's good to know about it, and we want to teach you through our program of the importance of specifications and standards and some ways to read them. So in this course, you're getting a little bit about how to read them, but you're getting a large amount of these resources given to you that hopefully you're compiling and you can read them if and when they become necessary. So let's take a look at this pest prevention by design. This is a really nice one, but I want to bring up, you've seen details that look sort of like this. Let me make it a little bit bigger for you. You've seen these types of details, and this is calling out important things about pest control in this case. So this allows water to weep, but keeps pests from coming in. So that's called a weep control, and it keeps out ants, spiders, subterranean termites, dampwood termites, miscellaneous destroying pests, and insects. So there are all sorts of things that you do. Now, this lap siding that's put on here that goes over the flashing, you'll see that there's flashing and mastic. So that's water control. And since this is an open area, since it comes down over the top, you need to keep pests from getting up in there and eating their way through stuff. So this one is a water damage control, and this overlapping of the stucco and the stucco board and the backing board and the flashing is all part of it, and you've got this. So this is why you want contractors that know what they're doing. Most contractors would just know to do this, but they'd want to look at your details to make sure that they're using the proper grade and the proper distances that are being called out. As an example, in this case, they're calling for 8 inches minimum. In most of the Sacramento area, we call out 6 inches minimum. But that's cool. And look, for corrosive environments, this needs to be an epoxy coated thread. So there's another piece. And you go, what's the big deal? It's in concrete. I've done a lot of work with stainless steel, even in the ground, stainless steel pipes, and it gets corroded. My gosh, corrosion is incredible how it happens, and it's not just from water. So epoxy coating is one of the ways that you create an additional barrier that works very well. And you'll notice that it even calls out a grade right here. So there's all sorts of details that happen where the building meets the ground. So grade is for moisture control. The overlap is for moisture control. The weep screed is for pest control, moisture control, flashing and mastic, moisture control. So a lot of this is moisture control, but wherever you get little openings or places that insects can go and live their merry way for a while, they usually have pest control too. So this is a really nice presentation. It's from some group in San Francisco, Department of the Environment. And they're one of the leaders in green building design. They were one of the first adopters of green building best practices, even before LEED took off and before Title 24 Cal Green took off. So the city of San Francisco does a pretty good job with this. And this is just a very nice overall presentation of it. And then these are their actual guidelines, 89 pages of guidelines. And here, look how to use the guidelines and structural emphasis. These are not standards. They're best practices, and there's a difference. Standards, you can say you must follow them, and you can put penalties on for not following them. Guidelines are things that help the designers do the best job. Often the guidelines will follow or meet standards, but sometimes there's extra. So you can look at this and see what's in here. There's a lot in here. Pretty good group of people are part of it. And then when you just look at it, this is really nicely done. These are all areas that have green design, but most of this green design is also about keeping pests from happening. So that's a little bit about pest, and you could look up more, but those I think make good reading for it, and you can do your lookups and things like that. Let's talk about wood itself. Since wood is one of the primary building materials, I put this one together for the class. So there are types of wood damage, and if you know the type of damage that you are interested in stopping, you can do things to mitigate or minimize the problem. So there's dry rot, and that's where something has started the rot process. It could be moisture that started it, but there is something else going on. It is no longer wet, and the cellulose is still degrading, so it is rotting. There is pest damage. That's damage often from beetles or termites or things like that. Could be from birds. There's just plain delamination. Many of our building products are layers, thin layers of wood held together with some sort of glue, formaldehyde being the main part of that glue. And under certain circumstances, that glue can just degrade. Most glues are what they call hygroscopic. Boy, did I learn about that in my career by making a terrible design decision, not keeping in mind that the material could let water through, and it did delaminate. It was with urethane instead of with wood, but most product is hygroscopic, which means that water can penetrate in some way, and most glues fail when water is present. And so wood that is laminated has a real potential for coming apart when water is present, which is why when we use laminated wood for roofing and walls and flooring, we have to be very, very careful about water. And of course, wood is very susceptible to fire damage. So is steel. Concrete, not as much, but it can be degraded by fire. Steel can be degraded by fire. Plastic can be degraded by fire. Fire kind of damages everything. So let's look at dry rot. Here are examples of it and something that you can read about. And here's a a little Wikipedia about dry rot. Here's delamination. Okay, so here's some construction concerns about it. And also fire can cause delamination also. So you can see a nice picture of it. Here, of course, is um, boring and wood destroying insects. So you can look at that and see what happens. And of course, we've got fire damage. So this one will lead you to a number of different types of damage. Here's a nice primer. This one's from the EPA, United States Environmental Protection Agency. Usually, if you can find a publication by a consensus organization or a governmental organization, you can bet that it is been well reviewed, and there's lots and lots of input, so you can rely that the information that is given is useful and correct. Now, it might still be too focused for your needs, but this is really cool. We were talking about sustainability and things, so here's moisture control guidance for building design. And we know that if we can make our building last longer, it will be higher on the scale of green. So this is a really, really good one. And this one's 144 pages long. Um, but it really gives you, site drainage, HVAC. HVAC is heating and ventilation. It drips. It evaporates. Water gets all over things. And then, of course, dampness and mold is a big problem. It is very hard to get rid of mold once it gets into a building, and it's very, very expensive. So this is 144 pages of information. If you're interested in learning how to read these things, you can let me know. And we try to put together a RAD class. There was one made available to you this semester. I'm not sure if anybody took it, but they teach you how to read these. It's very useful. So here's one on moisture. And then we've got just a little one on fire. This is by James Hardy Building Products. So now this one is by a manufacturer. And so you might take it with a little bit of a grain of salt, except for the fact that these people are one of the leaders. Their products are well tested, well designed, and they are one of the few of the building product siding manufacturers that present all of their data as open source. Okay, and so now they present it in a way that gives them very, very good reviews. But look, this is they have partnered with AIA, American Institute of Architects. So that's kind of cool, right? And so you can look at some of these bits of data and see what's going on. I've done work with Underwriters Laboratory, exterior materials and hidings. And I'm not sure if you're aware, but there's a huge problem in Great Britain in their public housing, where for cost and looks, Alcoa was accepted as a siding manufacturer, and it's an alumina based product. And if alumina is one of the most it combusts like crazy. It's right there with magnesium. And so aluminum is often considered to be fire resistant, but there are many classes of aluminum that just, burn like crazy. And they clad tons of these 5, 10, 20-story public housing projects, and they've had a large number of deaths from fires that have started inside of a unit, and then it just engulfs the entire building because of the siding. Although it looks good and it's weather resistant, it is very, very poor for fire resistance. And it's actually illegal to use in the United States. And it is now illegal to use in Great Britain, but they haven't fixed them all. So exterior materials and siding is also a big thing to look at. So this is a really nice, a nice little site, and it leads you on to other ones. These best practices, architectural research, master specs, master format specs. And here's their fiber cement building products. And they have a lot of them. They are tested according to a national standard, CAL FIRE exception. And now AIA doesn't endorse any of these, but they're saying, hey, these are some good things to go to. And this fiber cement, I think this is it right here. This goes over to here, and then all of a sudden it gets you into their system of finding information out, technical bulletins, technical documents. So this is a method of doing research and just looking and looking and looking until you get more. So there we go. That's sort of the information for this week. There's nothing that you have to turn in. There's nothing that you have to look over and go over. But my strong suggestion is that you put these links into your library and move. As a matter of fact, next week, that's part of our, I think next week is our review, right? Let's see what comes up next week. Review. So part of your review is going to be to go back and create a library for yourself with some notes and have your resources all put together. That's the best way to do a review that I know of, is now that you've seen everything, go back and glean what is important and make sure that you have access to that information. So sort of a preparation a little bit for next week. But there we go. That's what's up for this week. I'll reiterate, there is nothing due this week. Nothing is due. This week is professional development. But there's some good sources for you to read on your own. So there we go. I hope you all have a good holiday, a safe holiday, a happy holiday, and we'll check back in next week for our main review work. And then we'll be ready for our last week after that. All right. Have a great holiday, folks. Bye.